live. Give this a second to see if YouTube's going to be happy. Waiting. I've got this set on normal latency or low latency so we can get 4K without problems, and so it takes a bit, but it looks like we're probably good. Let me set to confirm. Maybe. I actually have some network traffic happening at the moment too, so let me just check my gateway. To me it looks like that's stalling a bit. Yeah, I got a bit of incoming traffic, but not enough to saturate my link, so I should be okay. Could be just reviewing YouTube, maybe. Not sure what's going on there. If anyone's there in chat, if you can let me know if that's screwing up or not, because I'm not convinced it's working properly there. OBS isn't reporting any dropped frames, and YouTube is not complaining at all. That's annoying. Alright, we'll move on for now. If people say we've got problems, I'll go back and have a look. So what we're doing today is, I actually run an ultra-wide Samsung monitor. It's like a 49-inch thing, but I use Xrandr to split it into 3 virtual monitors. So I've got like a center, left and right. And that's great for productivity and my general working, my general workflow. But it's no good for my gaming when I want to play games, because my virtual machine, as you can see, is running at the native res of my screens, which is 50 something. Now YouTube is complaining. Yeah, but I'd like to fix it too for future. It's telling me my bitrate's too low, but that's not true. My bitrate's like 2500 kilobits and I have 40 megabit upload, so it shouldn't be too much. Let me just, I'll back it down a little bit, just in case. Where are we? Just have to restart the stream for a sec. I think YouTube lets me do that without restarting the whole thing, but give me 1 second. I know that did drop, did it? No, it didn't. I've got to restart. 1 second. Yeah, exactly. No, that's why I backed it down. We'll see how that goes. If not, we'll back it down a bit more. Already it's looking better. It might have been just a bit too much. Can't wait for an Arc GPU so I can encode in AV1. That'll improve things so much with this kind of thing. Anyway, what I was saying is, my desktop output, as you can see in the guest, is like 5120 by 1440, I think it is. Go display settings, we can actually maybe see it. Where are we? It's hard to read, I know, because it's scaling the whole thing. But yeah, it's obviously unusable. There you go, 5120 by 1440. Now i3 does have the ability to go global full screen, and I've got a key bound for that. So I can just like go Control Shift F, or sorry, Mod Shift F, and you'll see I'm now in full screen. But that's clipping off the edges because it's wider than my stream, obviously. It still is dropping in and out the feed. That's so annoying. I'm going to drop it a bit more. It's half it. Wait to catch up. I actually was doing the other week without problems. So I'm actually surprised it's having problems today. I've dropped it down again. I did switch to a newer kernel the other day for debugging and testing. Maybe it's changed something with power states, because it was a power state change I had to make. Keep an eye on it, but the system I'm running is well and truly up to it. It's a 16-core Epic. It's a beast of a machine, and I'm encoding on the AMD GPU, so it shouldn't be doing too bad. Anyway, so let's get this on screen so we can see. Bring this window up. i3 APC. So i3 has this inter-process communication protocol. It's pretty simple. It uses a socket, so we're going to have to get access to that socket by obviously running that command and build these packets to send to i3. Specifically, we want to send the run command. The run command will allow us to send the toggle full screen global instead of just doing full screen. I've already opened an issue on GitHub and it's been confirmed that there is no way to programmatically tell i3 through like an X11 Atom or something. We want global mode because it's not standard. It's not part of the EWMH specification. So we have to find another way to do it. So this is the alternative. Yeah, so we need to basically implement this. Now I've had a cursory glance over this, so you're gonna have to do a little bit of fiddle and figure out exactly what we need to do here. And we also need to do it whether or not, like got to detect, are we actually on i3? And we already actually detect the window manager in Looking Glass, so we can identify it that way. Also running this, of course, will give us a the socket to connect to, and if we can't connect to it, well, then we also know we're not on i3. So there's a few ways to determine for sure if we're on i3 or not. We'll need to add a configuration option as well to ask if the user wants to use global full screen versus full screen if they're on i3, and we only want to present those options in the Looking Glass help output. Let me just go back here. In the Looking Glass help, we only want to present those options if we're on X11 and i3 is available. So we need a little bit of logic to add a section in here, like another thing, like we've got one here for Wayland, for example, and one here for Pipewire. I think Pipewire is a good example for code to look at for how to do this, because if I recall correctly, we don't show this at all if Pipewire is not installed. So we can go back and refer to that code as a reference. Sure, mate. I'm pretty sure by default these all become VODs anyway. If not, I'll figure it out. We've only really just started though. You haven't missed much, mate. I think the stream is working. Okay. So there's a fair bit of stuff to consider here. You're also noticing on my personal config for my system, etc. So the first thing is we're going to be editing the code in the display servers X11. Actually, we'll just go there. You'll see here we've got all the X11 interface code. There's actually a Wayland directory there too. But in here, currently we don't actually expose or present any options to the user when using X11. So we're going to need to do that firstly. Secondly, we're going to need to pull in the i3 support for it. So we'll probably make a so I don't want to hard code all this into here. I sort of want another abstraction layer. So we'll probably define an interface just as a struct with function pointers and have a default one that just sets the property for full screen. It's going to be very basic. There's not many like this. This is really the only thing we're going to do that's specific to different window manager at this point, but plan for the future. So I guess we'll call it wm.h for window manager. Let's go and grab our copyright header and if defs. Oops. Get the copyright date. X11. The X some display server, and this is window manager. So what I'm going to do is define a struct that will be a struct of function pointers. What we'll call this X11 WM. That'll do. Oops. And we basically just want a function to go full screen or not full screen. We don't even need a return on that. Don't need a true or false, or do we? We probably should return a success or not, because there might be instances where the application requests full screen that doesn't get it. So we can always change this later if it's wrong. This is a function, so this is a pointer. What we'll call this. We're going to need standard int. Set full screen, enable will do. This needs to finish the type def. Maybe also have in this the window manager name. Ooh, I think it would hard code this. Like as in which window manager will hard code the detection for i3 and pick up an i3 one, otherwise we'll fall back to a default. So we'll go maybe make a directory for this. Default C it'll be. This is an experiment, by the way. This is not a planned feature. It's just something I can see being useful, and if it's not too complex to add and it's not going to bloat the code too much, it's not a big deal to add and support this. So just a bit of an experiment. This is how most features in Looking Glass evolve. They're sort of an experiment to see if it's useful, not too hard to implement, useful to me personally as well, or maybe some particular group in the community. We'll experiment, see if it works. If it does, we'll push the code up. So what was this? Set full screen. But now, and false stub, and we'll make this. We need to define that struct. We also need to pull it in. This is in a subdirectory. We might actually move that too. No, we won't. We'll keep that there. It says the application, the client directory is actually in the search path for headers. So if we just go display servers x11wm, we'll get the exact file we're looking for. And then we need to define our struct for linking. This is, I guess, default. initialize it. And this can be static. Pretty sure that's correct. This here needs to be not static because we're going to have this defined in a header, and we're just going to use the WM header. What? Ah, I'm going into the wrong place. We're already in that directory. We'll actually fix the case on that too. X11 window manager default. And this is a X11 WM default. And we need to also copy in the make list, or we'll just add it to this one. We actually don't need the complexity of another level of make files in this case. Default. No, this is wrong. Here. Let me just do this. Down a bit. Yep, so we'll just do a make. No such display service client. That should have worked. Let's just go verbose. I want to see what's on the path. Where are we? Up here. Yes, so we've got the client include directory on the path. Oh, of course, yeah. I don't actually bring in the top level, that's why that didn't work. Just trying to remember what's actually in the path. X11. Source, what? That's a weird path to have in there at all. Doesn't even exist. And that include the current directory, so that's fine. And in this guy, we can now just say, because we're in that directory, let's see wm.h. That's better, but he doesn't know what bool is because we didn't bring in standard bool. Should I camel case that? No. So we'll fix the other. Yeah. So what I've done there is I've made a struct with a function pointer that points to this code here that we can call later. We might need to change the interface a little bit, but this is basically like writing an interface in C++, but this is C obviously, so we just create the struct and we can assign function pointers statically. You could also do it dynamically and just change the addresses, the pointers, but we don't need to do that in this application. You could even like pass an object, like a void pointer, and create like a constructor destructor paradigm, where the constructor allocates and returns a void pointer, or a pointer to a pointer, of the what do you call it, object it created that it can then handle internally. So anyone that says you can't do object-oriented programming like you can in C++ in C, well, they're wrong. We do it all the time. You get a bit more control too, but that's not always a good thing. In this application it is, but in other apps maybe not. Yeah, 4K, 2060 at 30 frames per 8 megabytes per second. Sorry, just reading this. 35 megabits per second. Yeah, no, I was running it at their recommended, because the actual interface tells me what I should be running it at, which is 23,500 kilobits per second. But at that, it was doing just as bad. But now it's telling me my current bitrate's 1128 kilobits, so I don't know. It might be an encoder problem. Actually, hold on. Let me try this. No, I'm dropping frames now. That's weird. OBS is telling me I'm only running it like 1,000 kilobits a second. But if I bump it up by an order of magnitude to, as if there's a mistake there, it then tries to crazy high bit rates. Something weird's going on. Well, it's dead smooth on my side. There's something wrong with the encoder. As long as you can read the text, it's not like the text is updating frequently. Okay, so now we need to create an interface. Not interface, we created an interface, we need to now implement this into the standard one. So X11C. Damn. What can I do to improve that? Let's kill the spinning logo. And get that off the screen too. Now more bandwidth is given to the actual text on the system. Wait for it to catch up.
Office of Civil Defense, Washington. When a nuclear bomb or missile explodes near the ground, great quantities of earth and debris
In the meantime,
are into the fireball and carried by the prevailing winds before falling back to
let's bring in.
material is radioactive. Fallout gives off invisible gamma rays like X-rays, and heavy exposure to it can cause serious radiation sickness, even death.
That fellow.
Further information about fallout and how you can protect yourself against it, consult your local civil defense office.
Full screen. See, we set this hint full screen, and we get a call back telling us whether or not we're in full screen. We don't need to worry about this. This bit doesn't change no matter how the full screen is set. We only need to worry about how we tell the window manager we want to go full screen. So we actually do that by changing the property here by sending an X event saying we want to add the full screen property to ourselves. And then the window manager, in this case i3, decides whether or not we can be and adjusts it. If not, he removes the property from our application and informs us it was removed, so we didn't actually get full screen. So all we have to do here is, instead of doing this directly, we call our function pointer. So before we do that, we need to we actually have a header here for this. Been a while since I've touched this code. So this is the state So the display server, and we'll put in here. Actually, we should have pulled the header in here too.
Now to make a family emergency plan. And then
Not there. We should put it under here. So point it to our window manager API. Bring this fellow. And then back in the event to set the full screen, instead of calling that directly, X11, which is our global state, X11 window manager set full screen. And all of this moves into that. This won't work yet because we're not initializing that pointer. So this is the default implementation. And we need to include H so we get access to the atoms and the window state. And in this case, we're just going to return true. Actually, no, like I said, we don't actually need that at all for this callback because we find out. Did VI fix the indentation for you on paste? You can make it do that. I don't. What you can do is use visual and select the whole hypertext, and then I can, you can either just press the greater than or less than symbols to indent by your configured indent level. Or you can type a number and say, like, I want to indent, say 4. So type 4 and then greater than, and it will indent 4 sets of indentations. So we're going to get rid of the boolean. I just make this void. Oh, VI is really powerful. I barely scratched the surface with my usage of it. I know that there's a lot it can do I don't use it for. Like, it actually can do code completion, and I don't know if they call it that much anymore. What do you call it? You know, where it looks up a list of functions and stuff. If you set all the paths and stuff, it actually can do autocomplete. I probably should learn to do that at some point, but I don't really use it anymore these days. I think I need to pull in atoms as well. Yeah. Yeah, IntelliSense, that's what Microsoft call it. I'm pretty sure we're going to get the right X headers from that too, so let's just try and build. We're not calling it FS, we're calling it enable. You can actually run commands straight from it too, like that. Not that I'm in the right path at the moment, but it actually supports debugging as well from Vim. It doesn't work very well in my opinion, but it can do it. It'll step code and everything. What header does that come in on? We're in the right path. Pretty sure that's just the extensions. One of these. Just test them until we find the one we're looking for. Let's see if that builds. No, it didn't, so it's none of them. I can't remember which header has that in it. Google's our friend. Xutil. I'm not even pulling that one in. Or is that one of the ones that I have to define? Yeah, I've defined it. Yeah, it's right there. I'm blind. Blind as a bat. Let's move that into X11. Header. not all of the definitions are in the headers. That's part of the problem. With some of the X11 stuff, it's not very well documented. Or they're defined in a header that's going to make me pull in stuff I don't want to pull in as part of the build system for just a few little bits and pieces. And these don't change, they're static. So this still will not work, although we are compiling now. The reason why it won't work is because X11WM is still void. We haven't initialized it. So in X11 init, we do that here. X11 default, and this is a reference to that. Like this up. I like my things to align. X11WM. Now that will work. So we can launch that. Oops. And we can toggle the screen. That's now running via that interface. Now it should be clear now why I did all of that. I can now actually swap this out to a i3 specific one. So if we go into here and we'll just copy default to say i3.c. And we'll change this, all of this from default to i3. None of it's changed yet. Also change this to i3. And in the header, also define it. That should build. No, it won't, because it will build, but it doesn't actually do anything for us because I haven't yet added it here. Compile that fellow. Alright, so we have two identical implementations, but in different abstracted away functions, which is nice. So in here now we can detect for i3. So when Looking Glass launches, if I just wrong side, wrong path. If I just run that, you'll see we actually have an output here somewhere where it says checking for EWMH support, and it detects i3. So we can actually use that. And that checks it here. This is part of our init code, yes. So we'll initialize it to default, and then if we detect it's i3, WM name, and we know it at this point because we pick it up. If well, good. If WM name equals, no, this is not C, C++, so I knew this is C, so string compare name i3, see if they compare. Then we can, actually you're right, my bitrate has jumped back up to 1500 kilobit, and YouTube is now not complaining at all. I don't know. Let's try this. This has got a bit of motion on it. We'll stick that back on there. So if it's i3, let's change out the thing. Wow, look at that. Yeah, I can see it in OBS too. It dropped back down to 600, and now I pull that out, it's back up to 1500. That's weird. I don't know. There should be constant bitrate. That's what it's configured for. Anyway, yes, I have to do some experimentation offline and figure out what's going on there later. Displace note window manager equals X11 i3. pointer to. Maybe we'll just put a little... Actually, no, we won't do that. I just want a confirmation it's detecting it just while we're testing. And here we'll just go... There it is. Get rid of that. Actually, we'll keep debug header. It is handy to have. So we probably also want an initialization function. Not just assume that this is going to work. For example, if we can't open the socket, we want to fall back to the default implementation. It's a standard init. And in i3, we've got to go init. Spool. Let's return false for now. For the compile test, this should have had void in it. In X11. Oh, we also need to do it in the default handler. Default init. Default should always initialize, it's our fallback. It's 11C. Alright, so at this point we've selected the correct window manager. So after we've detected the WMH. Yeah, so after this we should try and initialize because at this point it should be set, and if not we'll fall back to the default. Or should we? No, we should do that different. You see, we've already got some stuff in that's specific to i3 as well. Maybe we can also clean up some of the code with this later as well. We can just do that. If it initializes, actually we can even do this, and it initializes. So this will not initialize onto i3, which there's no way to tell because I've got no output there, but that'll fall back, not fall back, but it'll retain on the default, because currently i3 is going to return false. We also need a deinitializer so it can clean up. If you're curious as to what this music is, this is Slay Radio. This is like Commodore 64 remixes and stuff. And for default it does nothing. i3. Now it does nothing. But it will need to do some stuff because we need to close a socket and stuff. What's wrong there? Returning non-void. In default C. What did I do there? Bull. There should be void return. See, that was like an interface. It actually just enforced my prototype was correct based on the type defined in X11WM in that struct. So now we need to update the play server code to correctly shut down and call it. Yeah, so that's right there. Hey Pumpy, how you going, man? You'll have to excuse the stream. We're having a little bit of trouble with bit rates and stuff. I'll figure it out later. Well, see, the Windows API, if you want to, all you have to do is map the memory. Once the memory's mapped, you can use the shared memory for whatever you like. If you want a sample of how to map it, you can have a look at, probably the most concise sample is the test application I wrote for the IVSHMEM driver itself. Hold on. Let me just look that up. This here. I jump across to that, and that I can show it. This one. In the actual test, it's C++, obviously, but this is implemented as per how Microsoft Code is normally written because we had to make it to get it accepted into this project. But it does everything needed to send the IOCTLs to get the device size, to map, unmap, request its size. It's sort of a test of all of its functionality in order to verify the driver's working properly. But it's also a very short, simple, concise bit of code that does everything needed to map some memory. In this case, you probably want to look at request mmap, and once you have the mapping, which comes back in the mapping config, you can then access it, typecast it and access it. So hopefully that's helpful. Oh yeah, it is in the main code too, and I've tried to make it fairly simple there as well, but it's not done very easy. Whoops, I'm showing the wrong screen, but that doesn't matter. Look at this, YouTube complaining. I'm curious though what you're doing with it. Like, Looking Glass has really, really niche requirements, which is why the shared memory device is needed. For a lot of other applications, you probably want to more look at a user mode driver for, not a user mode, I can't remember the name of it. UEMU has like a VirtIO user, that's it, VirtIO user. Yeah, VirtIO user, and it lets you basically implement a driver for Windows, or for your guest, in user space across a socket with QEMU. But the only downside is you'd have to write your own Windows driver and sign it, and that's where it gets complicated. But if your guest is Linux, it's not so bad. That didn't exist when we started on Looking Glass, or it did, but it was like really, really basic. It was not useful for us. Anyway, so at this point we've called init, and because we successfully initialized it, we will set it, but we got a problem here. In order to be consistent, we need to also initialize the default one if we're not using this. So this is a bit nasty, I don't like this, but just pondering if this is the best way to do this. I think you dropped a link to your Rust code in Discord the other day. I did have a peek at that. I haven't written anything in Rust yet. I'm wondering if I should not even bother checking for i3 here. Instead just call init on it, and if it fails we know it's not i3 and allow it to do it in there. Instead we'll store the WM name and pass it in. Maybe. I'll catch you later, mate. Thanks for joining in. Yeah, it must have been someone else. I think it was Rust. Maybe it was Go. Where was it? They dropped it in the Looking Glass Dev Discord. Yeah, it was Go. It was this guy. It's pretty basic. I had a poke through it. I don't remember if it supported Windows. I think it was just talking to the Linux side of things. I don't remember. No, we will keep it this way for now. Just keep it simple. Else, I don't like that I am initializing it and changing it here, but we also set it elsewhere. But we need it set. I don't know if that, I wouldn't use that as a resource to learn from. I can't vouch for it. I mean, sorry, not, I wouldn't use it. I mean, I'm not vouching for it. So your mileage may vary. I just had a peek at it when it was posted. I don't like this. I don't like this. Let's do this a little bit different. We won't init. We'll just do this. We'll set it. Then if it doesn't initialize, that's a better way to do that. I know it may not seem obvious as to why, and I'll get to it in a minute. What's wrong there? Not operations. What? Ah, I left the equal sign out. Let's say later we want to add, say, KDE, and then maybe later GNOME or so on, and keep adding different window managers. We want this order to be easy to make into a nice loop or something to loop through each one and test for them or whatever, some nice lookup here. So we just started off to begin with. So then we'd say if it's i3, then that. If it's GNOME, then do GNOME, and so on, and repeat. And then this final init, and if it doesn't init, fall back to default. Doesn't get repeated over and over again with complex if-else logic. So it just falls through to the one that matches. But we still have a problem here. Because if it's not an EWMH compliant window manager, it'll never be initialized. The default one won't. Even though there's no code in there, we got to count that at some point in the future someone might add some init code in there and expect it to run, and then it doesn't for some reason, and like makes it hard to debug. That's X%. Where's X in it? X11, yeah, we want. See, initialization. I know. I know. Check support, which doesn't matter if that fails or not because we deal with it if it doesn't. We set a flag if there's no EWMH support. Here is where we should do that test in it and fall back to default, not inside that function. That way, even if there is no EWMH support, it will fall back. And all modern desktop managers where we care about this stuff supports EWMH, so this will always happen and will detect GNOME. But if it doesn't happen, come on. Yeah. And if this fails, we have a critical failure. I believe this has got a bool return. Oh, we got to go to fail. Okay. Yeah, fail window still a clean exit point. Okay. We actually don't create anything else. Oh look, that's a bug. This shouldn't go return false. This should go to fail window. The reason being is our label fail window destroys the window and closes the display. If we just return, that won't happen. Cleanup code. Now let's commit that as a separate commit. Fix cleanup. If what was it? That was X input, wasn't it? I'm going to replace entirely. There it is, if xi query version. Yeah, C does give you a ton of control, but also it gives you a ton of control. I like that statement, it's very true. C is my preferred language. Rust and Go and whatever it is, anything basically that helps prevent you from leaking memory, I don't see as being a negative thing, but it also means you become somewhat protected from some of the more advanced things you can do, or the more advanced things that are more performant become harder to access and do. It's also, I also like when I don't like getting memory leaks, of course. I don't like having issues where memory overwrites things that shouldn't and stuff, and tracking them down. But when you discover those bugs, track them down and fix them, the gratification you get of understanding the problem and finding the problem and fixing the problem is sometimes very satisfying. Like it's something that really drives me to the language, is the fact that I like that challenge. I don't write nearly as many issues like that into my code anymore. As you might have noticed, my development process of this interface wasn't to just implement it, hack it in, and then hack on it, which is probably what you do in other languages that manage everything for you. My mindset here was create the interface, create an initializer, create a destructor, make sure the initializer and destructor are called, even though we're not allocating anything yet, we're not freeing anything yet. Make sure we have an interface there that's really simple for the developer to see the code flow of how things work, and then it makes it natural to avoid those problems. Your code naturally will clean up. In this instance, this actually wasn't a huge problem, having that return false, because when the application terminates, because this window, if it doesn't get created, if the display server returns false, it's a termination event. Looking Glass is just going to exit, so I couldn't create a window, at which point the kernel does all the memory cleanup. It's not a huge deal, but it's incorrect, in my opinion, to exit with memory hanging like that, because you might reuse this code later in a way where it may fail, but the application doesn't terminate, and then you have dangling memory. It's just a matter of disciplining yourself to write code in a way that is safe. Anyway, where were we up to? So we cleaned that up. We were doing the deinitialization code for if this fails. So if this fails, we're going to get a fail window. But we should actually call it here. Oh wait, no, that's the wrong pattern. This application uses a pattern that if an initializer fails, we don't call it deinitializer. It's invalid to call it. We should treat it like the object's invalid entirely, so we don't call it st in it. So any cleanup is the responsibility of the, in this case, the default handler, or, well, yeah, in this case default, or in i3's, the i3's handler. But we do, if we succeed when we clean up, need to clear it, call it. So in here we have x11 free. We let it do all its cleanup and stuff, and just before we close the display, we'll go deinit. So that's all our hooks into there that we needed to make this work. Now it gets to the tricky bit of figuring out how to implement this in i3. How to interface to the IPC. The first hurdle we got is, let me just change screens again. Let's just pop out the chat because I can't see both at once. The documentation looks fairly good. The problem that we're probably going to see is, I can get that off there too so it doesn't muck things up. The problem we're going to have is the IPC requires us to call a application to get the socket path. So if we jump across to that screen now, we were looking at this before. To establish a connection, open the IPC socket. The following code snippet illustrates this in Perl. So it's basically grabbing the path from this command, get socket path. So we need to use probably system or popen or something to launch this application with this argument and grab the output of this to get the path. Now it's not a huge deal. It's just boilerplate code that's pain, because that's the output. You can see it's got the path to the socket. So that's our first step, and then open the socket. It's obviously a Unix socket. This is where Google helps us a lot. Yeah, it's fairly straightforward to get the socket, but then we also have to implement the message and the packet payload. It looks fairly simple. It really does. I haven't looked too closely at it, but based on this, we're packing a 32-bit int and then appending our message, and that's it. We're also going to have to give it the window we want it to work on. I'm not sure yet how to do that. Because the command we want to send is toggle global full screen is what we're trying to do. Anyway, so let's draft i3 state. Let's call this i3. Create a local storage for local globals. Yeah, you'll find most protocols are at a high level very, very similar. Binary protocols. State. What am I doing there? Trying to think. Oh, I need to store the socket. Socket. I'll just sock. Socket's actually a command if I recall a function if I recall correctly, so we just want to call it sock. We also need... Oh, you guys can't see the code. Sorry. Right, so I created a struct called i3 state, and I declared it just as a local global. Actually, it should be static. It's only useful to this itself. In the initializer, let's initialize it to 0. Wait, that's the wrong argument order. It's memset, and it's a reference to i3. Well, i3. And we're going to need to include string. Because that's where memset lives. We're going to need to include socket, I believe. I can't remember off the top of my head. No. Actually, before we even bother with sockets, let's get the path. I don't think we can use the system command. It would be nice to because it's a single liner. Yeah, but it doesn't give us the output. We need to use popen.
You're listening to Slay Radio, home of Commodore 64 remixes.
Hey Michael, been using some time on PC, been life changer, thank you. You're very much welcome, mate. I'm doing very well. I'm glad that you're finding it useful. I'll just bring up the reference on my other monitor. Standard IO, actually that's probably already coming in from debug, but that doesn't matter. So memset that to 0. Let's try and execute the command. What we call is just file descriptor. No. Popen, it takes the command. Wait, let me just check the manual. No, we could just use popen on this. I was thinking of like exec CVE and stuff where you pass it an array of arguments. This actually handles it all for us, so we can literally just do popen, what was it? Get socket path. And then we should just read from that. Just let me check the arguments and type. Yeah, because P stands for pipe. So we're opening a process and getting its standard in, standard out pipe. In the case of a file. What does it want for type? Type argument is appointed to a not-terminated string which must contain either R or W for writing. We only want to read. And then if not FD, return false. So if it failed to open, and this is what I was talking about before in the mindset of programming and avoiding leaks. Before I do anything else, I'm going to throw my close in there. Fclose, FD it'll be, to clean up. And now they're both in there, I know anything I write in between here and here will not cause a leak unless I exit the function through a return or something. Fclose, it'll be pclose, sorry, because this is a pipe. So if it opens, we should be able to just do an fread from it, I believe. Yeah. Let's see. I haven't done this in so long, this basic stuff. What that prototype? So the results in the first argument. Now this is only giving me a short buffer. So let's just go. We'll just go path. I don't know, 1024. That's heaps. Let's read into path. Size of path -1. Size of each element to read, which is 1. Size of path. And the stream, which is FD. That's happy, but we also need to check its return value. So no, if we can't read it, like there's no output, we probably should just go to a label. We'll call this error. Close. Wrong way. Just to keep it consistent across the project. The reason I do that jump is we might have more places we want to exit early. If not, we can simplify that a bit, but for now we'll keep that. And just to make sure this is going to read out, let's go debug info. No. Just that should do it. We should get the socket on the output. We find here. There we go. But note here, I actually got an extra line. So this thing has a new line terminator on the end of it because this output a new line, command outputs a new line. So we need to trim that off. That's really easy to do. We could just say while stlen path -1. Sorry, path string name path -1. Actually, we're going to do a while because there's only ever going to be one. So if it's a new line, equals a null, because there's a null terminated string. And now it should not have. Where is it? I'm blind. There it is. Yeah, see, no new extra line there now. Yeah, that's a major gotcha people get when they're doing string parsing or getting commands or getting output from external apps, is they forget that there might be hidden characters there that then they try and open the file, and Linux is now trying to open a file that's got a new line on the end of it when it doesn't have a new line. It doesn't exist with a new line. So at this point we can close the socket. We're done there. Yeah, this go-to logic is overcomplicated for what we need here. We can just do this. That cleans that up. i3.sock equals fopen. No, it's not fopen. This is a Unix socket. So the other failure mode here could be that we don't have permission to open it. So there's still a chance this could fault. We need to look up. You know what? I'm going to jump into the code of we call it Pure Spice. It literally has this in here. I can almost copy and paste it. I did all that. Stock equals socket. AF Unix. Dot stream. That probably will fail because we don't have the headers yet. The header we need for that fellow is not sure. We actually need several, I think, because AF Unix and sock stream are not defined in the same header. It's just syssocket. Wait, log. We're working on another project where it's log underscore instead of debug, and I forget, getting it mixed up. So if we've created the socket, at this point we need to assume this is going to fail if we exit add, so
we can all be quiet and peaceable and listen to the music.
clean up. P close on socket. No, I don't mean that. I do mean close. What header is that in? Uni standard, maybe? Yes. And that's unused, that's fine for the moment. That Looking Glass is configured to throw errors if it's like to abort completion, treat warnings as errors, and we have a flag in there to tell it that we never want to have dangling stuff that's unused, dead code, etc. And it's currently telling me that code is useless because nothing refers to it, which is correct. Which again helps you to avoid a memory leak, because now I know that if this fails, there's not going to be called, and the compiler's saying that code's never going to be called, and so there's a problem. Well, that code's never going to run, I should say, not be called. Alright, so this is a Unix socket, so now we need to connect it. You know what? This was not the right project to reference for this. This is not either. So I'm just finding a useful reference. Not exactly the code you write every single day. And yes, that should be less than 0. It could be anything less than 0. This is binding. No, this is still not. I'm looking for a Unix example. Unix sockets, you have to do them a little bit differently. This address structure, use it a little bit differently. I can't remember off the top of my head. It's not code that we do very frequently. I think the last time I wrote anything that used a Unix socket was literally pure noise a few years ago. Here we go. Yeah, so this shouldn't be IN, that's for internet, UN for Unix. And we could probably initialize a lot of this like this because we're using C99, I believe it is. If Unix, that's the only thing we actually need to initialize. Let's just make that a one-liner. That we can initialize like that, I should say. We might use string end copy for protection on this in a second. Let's make this a little bit nicer in pathlen. Now we can make that a one-liner too. If you're not aware of it, stringlen, this is a mistake a lot of people make in a lot of languages. They'll like do a for loop on a string and they'll say for I equals 0, I is less than the string length of whatever plus I to loop the string. But every single iteration of that loop, it's going to then iterate the whole string to find the null terminator and count how long it is, and it's going to do that every single iteration of that loop, and it's a lot of overhead. So you're better off saving it off, and here we check if the last character is a new line. If it is, change it to a 0. This is wrong. This should be a post decrement. Change the last character to a 0. And then decrement this value. So it's all in one line there. Cool. And then here we can just go string copy this into pathlen. This is still going to complain about unused stuff. We need a different header. We need sysUN. Actually, we need standard up here. String end copy. Just source and size, yeah. And now we're back to complaining about it. So this is still wrong. This is another mistake that can be used to exploit your application. Yes, pathlen -1. If you're unfamiliar with C, this is a post decrement. Actually, you might have seen a for loop like this. I++. This I++ is exactly the same as what I'm doing down there, but it's a negative. Because the operator here comes after the I, this is called a post increment. So we read the value of it, so we get the value out of it, and then we increment it, so it returns the pre-incremented value, and then we add 1 to it. Whereas in this case, we get the pre-decremented value, which is the original value of pathlen, then we decrement it. But this -1 is going to happen on the pre-decremented value, if that makes sense. So this is basically the same as saying pathlen pathlen. Yeah, that's right. Yes, it is. They're both a thing, but they're different. They do a different thing. And I think that's the same in all languages. There's actually a difference between pre and post. So that there's going to be doing... I'm basically going to rewrite this little bit here just to give an example. Pathlen minus. Yeah, that literally is exactly what's here. Right, so pathlen, or it can be more explicit, is pathlen -1. The problem with a pre-increment is it changes to this. Or we can pathlen is pathlen -1. So the decrement happens first, if that makes sense. That's what a pre-decrement, would do. Which is wrong, because then we're going to change the wrong value. So we need a post-decrement, so we read the value, use it, and then decrement it. Hopefully that's clear. If not, I'll throw a little sample out and show you what it does. Pre and post decrement are different. Get rid of this loop. Actually, that's an optimization too. Some compilers, older compilers, these days it doesn't matter so much. No, that -1 is to do with the fact that string length, we're checking one character back if it's a new line, and then we want to change that new line to a null terminator if it's there. And we also then want to decrement the length because the length is longer than, like the length is one character shorter now because we moved the null decrement back. But yeah, back on the optimization thing, older compilers didn't do this properly, and they'll do this post increment. It was commonly taught to do this, but it was actually faster to do that because the pre version in this context doesn't return the value. Anyway, noting fetches at once rather than twice works a little bit differently in the optimization. But let's do this. Push D. We'll also pull in so we've got this here. Let's go not char star, it's just char. No, it's just char.
If you don't listen to Slay Radio,
Alright, I'm having a brain fart right now.
down your neck.
Let's just do this. Char path equals some example A, right? Let's say we want to get rid of that A. Let's first print this out. This should be const char. Right, as a little example. Right, so that prints out. So let's say we want to change that A. We go, we'll just go pathlen. String paths. Wait, what's wrong with that? I didn't pull in string. They were just warnings anyway. right? So if we print the character pathlen, it's going to print out the I think it's going to print the A. Yeah, it'll print the A. No, it's printing the line terminator. So it's got to be pathlen -1. The string length returns to the length of string including the null terminator. Right? So to return the A, we got to go -1. We don't have a make file here. So now we're getting the A out. So let's say now we want to change the A to a B. So we can go pathlen. I know I'm probably going a bit overboard when explaining this, but we'll go one step at a time. Oops, and we'll duplicate the print. Confirm it changed. Because we've got a const char. I don't know if we can do that. No, it's going to let us. Alright, so we've changed the last character to a B. Now let's say we want to shorten the string, pathlen, but still change it. So we'll replicate what we did in the other one, where it was pathlen -1. Oh wait, sorry, wrong line. I've got to do order of operation, otherwise you get 3 minus signs there and it's going to break things. Alright, so now this is going to change the last character to a B and decrement the pathlen. So this should print the lowercase e, right? But if we print the whole string as well, right? So we'll just print the string to get some example B, but this line here will print the E. See? A, E, and some example B. Right? If I was to change that to a pre-decrement, we're going to change the E to a B. So we're going to decrement the value and then use it. Oops. Got to compile it. See, look at this. We changed the wrong character. So pre-decrement means decrement the value and get it and return its value and use it. Post-decrement means get the value, decrement it, but use the value before it was decremented. Right, so at this point we've removed our terminator, we've closed it, we're opening the socket. We created the socket, we're now going to set up to open the socket. And that's fairly simple. That's literally just a connect command. We have to typecast ADDR. Oh no, it's fine, mate. I like explaining this stuff because some of these nuances a lot of people don't know or understand. And you are correct. I could get rid of the -1 and pre-decrement it, 100%. But it becomes a little bit harder for anyone that comes along to read this code later because it looks like a bug. Sometimes it's more important to be verbose than like the shortest possible code. Readability is an important factor. And to be honest, this here is possibly a little bit too concise and it should be done in 2 lines to make it more verbose what's happening there. But anyone that's really pouring through this code in Looking Glass as it is, being such a complex project, would usually understand this difference here already, because it's a fairly common construct to see. Yes, the string is shorter and that's why I got to decrement it. because we do want to make it shorter. That's the point. Anyway, the typecast here for ADDR, which is this guy, is because this prototype takes the this socket address generic type, and then internally it calls the right function stuff based on the family type of the struct. And we want the size of the full struct for safety is why it wants that. We can just say size of ADDR. If this is errored, we are going to connect to the i3 IPC socket. Go to socket. So that'll actually finally compile. Maybe. Output may be truncated. What? Why have we got that? That's an error I have not seen before. Output may be truncated, copying between 0 and 1023 bytes from a string of length 1023. Yeah. I do expect that. But we're never going to see a string that long. So why are you giving me a warning on that? Because I'm used to using this. This should be the size of the destination. It's a limiter, but it will only copy up to the null terminator. It's a string. Copying from a length of turn 23. So it's telling me now that it's going to exceed the maximum possible. So let's actually do this and use the size of what it can be. As our definer, we'll limit. We'll need to also move this up here. I'm now using it to define that. There we go. Fixed. It was warning me about a potential buffer overflow, or failure to copy enough because of preventing a buffer overflow. Alright, so now we've got the connection happening. We need to go to dinit and close the socket. And let's put a debug on just as a test. Just because we'll see warnings easier. No, we've got a problem. Failed to connect. So we failed here. Why? Connect. Give us some more info. No such file or directory. Look. Where's the null termination? We overflowed. Why don't we have a null? What the heck? Oh. No, that still should have worked. Let's print this out. Look, it connected that time. Something funky's going on there. I don't like this. This is too reliant on order of operation that is not very well defined. In my head, anyway. Let's just do it the simple way. There, you happy? And we got rid of that print. Let's see if it works this time. No, it didn't work. Failed to connect. And we got junk on the string again. So that didn't fix that. That -1's actually incorrect because this is a binary read. The if statement run, well, it has to because we did the print before, which stripped out that line. Can double check it, but and it worked that time. But you can see the if did run. We've got the path strip line there. Let's just run that again. Works. Works. Huh? Get rid of this print. Which it doesn't work. Doesn't work. And we've ended up with a bad path again. Haven't we? Yeah. What the heck? The print fixes it. Why? Not like this code's very complex or anything. Yeah, very bad fix. No, we're just gonna step the code. Alright. Oh, look at that. Where's the null terminator? I know exactly what's happening. Duh. I don't know why the print fixes it, but I know why there's a problem. Look, there's the new line. No null terminator, because I'm an idiot. And I assumed fread's going to return me null terminator string. It's not. It's not going to give me null terminator string. It's returning me a read into a buffer of up to that size. We need to take the length and null terminate it. In which case we can actually use parseIn equals this. Actually, undo that. And yeah, that. Window. So if it's less than 0, otherwise we know the parseIn already at this point. This is no longer a -1. We know how much we've read. If the last character is a new line, then let's just subtract parseIn. ParseIn should be null terminated. We can also close this a bit earlier. Yeah. Okay. parseIn should be the length of the path. Path will just be the buffer. So now we're going to... It didn't pick up the null. Why? What's print? What character is that? Oops. -1. Because that's how many bytes read. It's got to be -1. Pass lane -1. That would have correctly null terminated it. Oops. What? That still didn't run. Or did it? See, this is something interesting too, is the code we're actually stepping may not be what's executing because of optimizations. So let's just print path. We'd have to set it to 0 or whatever for that to be correct. But you can see it did work. We actually null terminated here. So now this will work. Yeah, that looks better. Connect. Looks like it succeeded. Sweet. Let's just make sure this is set to debug. No, it's not. See, that's why the stepping was weird. Yeah, see, it stepped into that correctly. That could have been why too the print fixed it, because of the optimizer was doing something funky in there to make it quicker, but also fixing it when we did the print. Yeah, okay. Sweet. So we've opened the socket. Means we can now talk to it, which means this code here completely changes. Now, or does it? Yes, it does. This completely changes. We need to construct the command to send to it. So how do I tell it? Let me just switch windows again. We need to figure out how to tell it what window. So the command we want is toggle. This guy, full screen toggle global, and this is a binding, so you can bind a key to it. Like I was saying before, if I do mod shift F, I've bound it to, I'll actually full screen that terminal window across all my screens. This here though doesn't target a window, just sending that command. So when using the IPC, how do we target the window? Yeah. So you run the payload as an i3 command, like the commands you can bind to keys. Run command. No JSON encoding or trailing new line, so that makes that easy. We don't have to worry about JSON rubbish. Wonder if there's a i3 message. i3 message literally just sends a raw command. It's basically what we're doing just on the command line. Maybe if somebody else has done this. Might have to look a bit more into that, but for the moment, let's just get it sending the command anyway. The window will be focused at the time it happens just because of how it works. We can't rely on that later. So the command syntax is very simple. We're just going to need a buffer. And we'll just struct. What was the format again? No, it's not const char, it's char. How long is this? And is it null terminated? Looks like it might be. 1, 2, 3, 4, 5. It's not sure. Magic string, yeah. The length of the payload is a 32-bit integer, but it doesn't tell me if the string is null terminated. We can infer that based on the samples. So i3 IPC message length should be 1, 2, 3, 4 because it's a 32-bit int, and the message type is what? Type is also a 32-bit int, so it should be 1, 2, 3, 4. It's not, it's 3 bytes. And 65 is not a type listed here. That's hex, but even still, that's way off. Like this, I'm pretty sure isn't going to be null terminated. It's i3 IPC. Of course, because this message length starts here. Sorry, one more. i3 IPC. String length starts here. 1, 2, 3, 4, leaving 4 bytes for the type. So yes, no null termination on that. So how many characters is that? 1, 2, 3, 4, 5, 6. Length, type, and char payload. And yes, this is valid in C. Having a 0 length field in a struct, it basically just is a way to easily reference the end of the struct, but it is valid here. In C++, it is not. And this will be i3 IPC, or i3 message, we'll call it. We're also going to need to pack that. Oh, sorry, I'm again on the wrong screen. You got to tell me if I do that. Not i3 attribute, oh, GCC. Can I remember the exact syntax? Alright, so we have a packed struct. Packed will stop it from adding things to align them, because if I just left that unpacked, it will align to 32-bit ints, and this here, 6 bytes long, is not the length or a multiple of 32 bits. Sorry, I'll give you the link if you want it. So now we can go. This, there we go. The magic is i3 IPC. The length, we're just initializing at this point, is 0, and the type, according to this, it was sending run command, which is 0. So let's define that too. We'll probably move this into the top of the file or into the header or something later. IPC. Run 0. I don't think we really need anything else but that one. This is actually wrong, by the way I'm defining this at the moment. Not boilerplate, temp code. Type is this guy. I could just put a 0 in there, but that's not explicit. It's hard for anyone that comes back to look at the code later to understand what that means. Verify length, type, payload, yes. Alright, so the reason why I did it this way, with this payload 0 and not defining its length, is this becomes a generic message struct I can use for any message. And to use it for this, we can say, well, our payload is the command toggle the. I gotta look it up again. Full screen toggle global. Yeah. So we can say our message is instead a pointer. Now I'm going to use allocate. If you don't know what allocate is, it means to allocate memory on the stack, not allocate it on the heap. This is much faster, like infinitely faster than a memory allocation on the heap. The only downside to that is you can run out of stack space, so you just can't do huge things in here. You can maybe do a couple of kilobyte, depending as well as how deep the call stack is. Like if you're 30 functions in and they've all got local variables and stuff, you might actually be very low in stack space. In this application, where we are, it's really safe for us to do this, so we can here. The reason why it's so much faster than allocating on the heap is because allocating on the stack just involves decrementing an int in a register, and that's it. Specifically the stack pointer. Anyway, we want to allocate the size of struct i3 message plus the size of the command -1, because size of is going to be null terminated, and I think the command isn't null terminated. Yeah, it's not. Okay. That'll give us the space we need, and then we can say magic length equals size of command -1. Message type is the run command. Now, size of doesn't work the same as string length. String length happens at runtime. It's going to iterate the string to find out how long it is. This is a constant string. It's never going to change in its size or length. And so we can actually say how big it is in memory. It's a standard char array, so each byte, each character is 1 byte. So the length of the string is going to be the size of it in memory -1 because of the null terminator. That's how we get the links, and that's becomes a compiled static. It's far faster. We need to copy that in. Mem copy, yes. We can't use string copy here because string copy is going to expect a null terminator. Message 6 or size of, not message, message magic. I could have just said 6 there. Actually, we probably should because it's the length of the string and it's clearer. Need to get rid of that one. Alright, so we've constructed our message and we should be able to send it. This is we're sending a struct, so we can just get a size of message. We're sending one of them. Let's read it sock. I've got that backwards. First argument should be the pointer. No, do I have the prototype wrong? Message, the size and the number of items. It's a socket, it's not a file, we gotta go right. And then the first argument is the socket. And it doesn't support that syntax, so it's just the size that we're writing. But in theory it should work, there's no error checking yet. Now I don't need to worry about freeing this memory either. Stack allocated memory is like a global, or it is essentially a local variable, and it will just deallocate when you exit the function, simply because the stack pointer will be reset to where it was before this function was called, thus freeing the memory. So you don't need to free it either. Freeing it's actually a bug. Let's see if this works. Nope. And don't be lying that I would put on there. Right, yeah, there we go. Yeah, so it's writing 8 bytes, which doesn't seem right. Okay, it's F right. Returns a number of... No, that's F right. Yeah, on success number once written is returned, error -1 is returned. Well, we're not getting a negative value. We're getting 8. 8's wrong, so we should have 6 plus 4 plus 4, so that's 8, 9, 10, 11, 12, 13, so it's 16 bytes already. Plus the length of the payload. Let's put a breakpoint on this. Make sure we're built first. And we'll run. Now I'll need to move this off screen, otherwise it'll, when it breaks, I'll be able to interact with the debugger. So let's try and full screen it. I can already see the bug. This is the bug here. Size of message is the size of the pointer to message, not the size of the struct. We'll check the struct while we're here anyway, but if you say print star message, it's all there except the payloads. We forgot to copy the payload in. Actually, we can just go message links. No, we won't. We'll do it this way because it's faster. Because it'll become static, like it'll become just a hard-coded number. This should be size of our message. Right, let's put this back up. There we go. Still not working, but we're actually sending 14 bytes now. That still isn't enough. This is what? 1, 2, 2. Yeah, there's the problem. Again, it's still a size problem. I only sent the header. I didn't send the payload. There we go. Global full screen works. Now the problem is, again, a focus issue. If that sends a command and I'm focused out here, which won't work at the moment because I'm not doing... I've got cursor follows focus turned on. It would actually global full screen the wrong application. But how's that? From scratch implemented on stream. So now we can say if... I really don't like all these sizes on. that one's fine. That one's fine. This one here I don't like. The reason being is this here we might use for other commands in the future and reuse the right line, in which case we want the right length to be dynamic based on what's in the header. So let's change this for error checking. I'm just going to send size, or just payload side actually, or message size. That's probably better. No worries, mate. It's nice to have you on. We're pretty much done here. I'm just going to put some error checking in here. I probably will finish up in a minute anyway. It's almost 1 AM here. And I've got a few other things I want to do. Plus, I want to go and play some games. I'm keen to just relax a little bit. Not that this isn't fun. But yeah, we're just going to do some basics like error checking here. And then probably commit and push once I've verified that this isn't going to cause problems. So we're going to go right. Message size. Alright, so actually it should be a const. Now, if you're doing socket programming, you should never ever assume this will write the entire message in one go around. Buffers might be full on the other side. The server might only be accepting 1 or 2 bytes at a time. You can't assume the whole message will get there, and you'll get random issues whether it doesn't work or you corrupt the data stream and the server doesn't know where you're at. So what you need to do is actually check the result, see how much was written. If not all of it was written, advance our pointers along, reduce our size to take up for what was written, and rewrite. And keep calling this until we're done. So we go, yeah, while actually let's also go int wrote. While we haven't written it all. Actually no, better way to do this, easier way to do this is just while message size greater than 0, which we can just say while message size. We write it, we check for error, and also how much we wrote. So if it's less than 0, we've had an error. The socket should be closed, and we should disconnect and throw big warnings and stuff. This also should be lowercase as well. We'll do a warning. We probably should close and reopen the socket because it might be that i3 restarted or something, but we'll deal with that later. It'd be rare if that happens anyway. We don't need to free or clean up, we can just return. But if we did succeed, we need to message plus equals, because message is a pointer to this allocated memory. Actually, we should use a char star buff equals. Do that, and we'll write using the pointer through the struct. And then down here we say buff plus equals what was written, and the message size is subtract from that what was written. That will ensure the entire message is written through the server if it writes it in small segments. because for whatever reason the server can't accept it, but that's working. Alright, the only other thing that we need to do here is currently this is enabled, period. We want this to only be actually enabled if an option is turned on. Whoops, there's a typo there. Not everyone's going to want this feature. We need to make it that you can opt into it if you want it. By default, it's opted out. So, it would be nice to prevent this from showing if it's not an option at all, but no deal breaker if we can't, and we probably can't because we don't know what window manager is running until we've initialized the display server, and we can't initialize the display server until we've got all the options. So chicken or egg problem, we have to assume that it's it might be available and provide the options anyway. Actually, do we want... Yeah, probably not. An i3 specific option. I think it's option, not options. Yes. And I did provide... No, it's config. I just want an example because the options syntax and struct format is I don't remember it off the top of my... I wrote the whole thing. Like I should know it off the top of my head, but there's so much here, it doesn't all stick in my head. Module i3. I guess it's global. The description, there's no short opt for this. Use global full screen. Don't know if I like the name of that option. Any suggestions? This is like the command line option to enable this functionality. I don't know, I'm overthinking it probably. Too long. That's better. X-bool to boolean value. Then we also need a null terminated value. Zero in that. Yep, unused, that's fine. Ah, okay. We need one more in our window manager. We need an early init, but like a setup call to allow us to register options. Void. I'll put some documentation in here too before we finish up. That's all we needed. You find what I use, but yeah, I think that code's right. Yep. Yeah, Looking Glass has a global options thing that I wrote to allow various segments or parts of the application to register different launch command line options and stuff. It's actually a really complex problem as you get to a larger application where you might compile in support for, say, X11 or Wayland or Pipewire or Pulse Audio or NVFBC or DXGI or all the compile options we have may make some of these options useless. Or you might run it on a system that doesn't have X11 or doesn't have Wayland to begin with, and then you don't want to present those options to the user. So we need a way to dynamically build the options. It's sort of a chicken or egg problem all the time, and that's what this option stuff I built is designed to do. We also need to put a default handler in here. No need to return, it's a void. We have to define them all, otherwise we'd call a null pointer and cause a crash. You could check if it's null before trying to call it, but we should do this early. I believe there's already a setup in here to allow specifically for this. Yeah. It's not a pointer because we're calling it by its name directly. So we should have new options here for i3 somewhere. There it is. Change the case of this. Distant. Pretty sure we use full screen. Oh no, we've got different case entirely. We are using Camel on the let's just call this global full screen. And we'll keep it like that to be consistent with the other options that are already in use in the public. Now, we also have to fall back to this other method if we're not going to be toggling full screen, like using global. In which case we don't need any socket open, but we're going to keep it open anyway, just because later we might use it for other stuff. We need to read that out. So an init three get bool default is false. The default's up there already, sorry, we don't specify that like that. So we read the value out, and then down here we go if if we're not using it, we can just call it default handler. return. Alright, so this will be the default behavior. And if we now set the option, global full screen, we should now get the full screen behavior. Beautiful. Absolutely beautiful. I'm super happy with that. That's really cool. At the moment, I'm actually not going to worry about targeting the window here. If it becomes a problem, we'll look at it. But to be honest, the shortcut to make it go full screen needs window focus to happen in the first place, which is the scroll lock F function. Actually, this will be interesting at launch. Yeah, see, it targeted the wrong window. And full screen, there we go. So there is still a problem there. We do need to target it. That was using the F full screen argument, which is running this code before the looking glass window has focus. Yeah, how do we fix that one? Here we go. Alright, it's not too hard. I think we can just do this. Prepare 6 and window ID by X. I know you guys can't see this, but I think we could just use a standard matching syntax it uses. And we have the win ID, so we can just do this. ID equals, and then the window ID. So we are gonna have to do a little bit of string processing here, nothing major. Not a pointer. I'm gonna use a command still. We're never gonna need more than, say, I know, 128 bytes. Plenty. This is 1, 2, 3, 4 plus. Let's say that's a 64-bit value, so that's gonna be another, like, I don't know, 16, 32 at the worst. Plus the rest, yeah, 128 is heaps. Let's make it bigger than it needs to be. Hey Jonathan, thanks mate, appreciate it.
Greetings, Master Yoda.
If you've just joined, we're adding a full screen toggle feature for those using i3 that spans all monitors if you want to go full screen. It's not something applications normally can do under i3 by themselves, so it's something special to Looking Glass. Just for safety, we use SNPrintf. The format's here. Let's put this across a few lines. And it's in the window. It's literally just x11.window. We know our own window ID. Now, this isn't going to work anymore, the size of, because the length of this can change because the ID could be a big or a little number and it would change its size. SNPrintf, I believe, returns the string length. check that. Yeah. So plus we could actually print it straight into the payload. Actually, no, we can't because we're allocating it to the right size to send it. Okay. Yeah, no, I use i3 exclusively, so this is something that I'd actually find useful too. My desktop screen is actually an ultra-wide Samsung that I use X-Rand to split into 3 virtual monitors. You're looking at the center one here. But when I run Looking Glass to play games or whatever, I want to run full span width, and the full screen toggle doesn't make it full screen across all the screens, it just does it for one of the virtual screens, and it's a pain in the ass. So this here uses the IPC to tell it we want to do a full screen global toggle, which then spans all monitors as an opt-in feature. Anyway, command len, we know the length's now there. I think the rest is fine, but we'll run this under a debugger and verify it from there. Not a const anymore. Long unsigned int versus long unsigned. Alright, let's run this under a debugger. I've got to turn the feature on as well. What was the argument? I3 set use, yeah, set args I3 global full screen, break on I3 set full screen, run it's off and try and go full screen. Drops us into that section of code. The command length is 39. Command is blah blah, full screen toggle global with the null terminator. We set up the message. Which got truncated because the result from the SN printoff doesn't include the null terminator. None of this should have been -1. Where was it? Command len will be -1. Neither should you. Neither should you. That should resolve that. Oh, we didn't set the breakpoint up. Whoops, we'll have to restart that. The reason why I can't just interrupt and add a breakpoint straight away is because Looking Glass itself will, well, the host app in the guest will think the client has hung, and it will evict it from the LGMP loop. And then we can't debug it, so we need to make sure this happens in the right order. It's actually fiddly to debug Looking Glass if you don't know what you're doing. Well, it can be. Anyway, look at that. Ah, damn. I just made a mistake talking about bugs in... Actually, can I get out of it? Yes, I can. I've lost control of my cursor, my mouse, because what's happened is Looking Glass had it captured, and then I caused the application to enter the function got a breakpoint, so it's hung. and it won't ungrab my mouse now. It can actually do it where it grabs the keyboard too, and the debugger steps in, and the only way to fix it is to either reboot system or SSH in from my laptop and terminate the debug session. Well, thankfully it didn't capture the keyboard here, so let's check the message. That's better. It's got the window ID on it, and it works. And that was a mistake too. I now need to pull my laptop out. Do I? Let me see. Can I? No, we're good. Let's terminate this before I break things even more. So in theory, this should now full screen the right window when we do this, or none at all. Okay, none at all. That's still a warning. We shouldn't actually have that in there. It's an informational message. And so default behavior works. And global works, but on the launch switch it doesn't. We need to fix that. How do we fix that? I already know why it's happening. The window is not yet exposed or visible on screen. In X11, exposed basically means it's visible. Because it's not visible, we can't full screen it. And i3 won't full screen it because it's not visible. So how do we do this in a way that's going to be reliable? Because this is now diving into the core code of the application. I think we should actually leave it for now and address that as a separate issue, because it's not actually going to be a bug in the code we've developed now. This is actually a bug in the core of Looking Glass, because that's a few different layers back up the stack. And it's an out of order calling issue with initializing and setting up for full screen. So I need to go through and review that and sort of dig out what's out of order there to make this work for i3. One of those occasions where it looks like a bug in the new code, but it isn't. But I'm happy with this, so I think I'm gonna commit and push this, to be honest. Just do a preliminary commit and review everything. No, there's already a problem. We need to add a couple of files. There we go. Now commit P means partial. It allows us to inspect each chunk and say yes, no, or just abort entirely the commit, like creating the commit to push. Or you can even edit them right here. So if you've, say, made a couple changes while developing that are unrelated, but one was like a bug fix, like I did earlier in this stream, you're able to split them out and make an individual commit for that one, keeping the commit history clean. See, that's one right there. And I think I want that commit to go in first. So say no, yes to this change, no to this one, and this, and this, and this, and this. Somewhere we'll see one where I've put those lines in here. I only want part of that commit. The WM change is specific to all the stuff I just rejected. This here isn't. Alright, so we can edit this commit, get rid of that line, right, and that was it. So now this is client X11 if X11 defines into X11.h. No, we've done this the wrong way around. Look at all this new file. They added stuff before. We're actually going to have to do this all at once. I'm not going to remove them out again. Oh well. Well, just so you know, you can do it. Right, X11. What is this? Add support for i3 global full screen mode. So now we've got a basic one-line description in the format I like it for the project that we follow. So it's in the client. It's the X11 display server we're working on here. Basic description of what it is, and now let's write a bit of a summary, which in this case will be this commit adds an interface to the X11 display server code to support various window manager specific features, such as in this case the i3 global full screen toggle function. This feature specifically is the i3 IPC to cause glass to full screen go across all monitors if the new option, what was it? Memory like a sieve for stuff like this. No, it's not even here, it's in i3. i3 globe. Right, you might notice that red line, by the way. You're not seeing it here because the screen split actually is hiding it. If I actually start a few letters out, you'll see it. That split is, that red line is to tell me that's 80 columns. So I try to avoid exceeding it. Now, a lot of people are like, oh, it's modern day, we got super wide monitors, 80 columns is a ridiculous thing to restrict yourself to, and it makes writing code harder. I completely disagree with anyone that says that, because anyone that says that has not worked on a large code base that is not using features, and they are using features such as Visual Studio's things lets you like minimize code blocks and stuff and pull everything in. It sort of cleans things up, makes it easier to navigate. But as soon as you throw this to any other editor, it becomes hard to work with. Plus also the human eye likes to follow horizontally up to a certain point, and it's hard to go back and find the start of the next line. So if you read all the way from the left to the right and then trying to find the start of that line you were just on all the way on the left, continue, it's really hard to find it to continue, and you end up searching for it all the time. But with a limited width, it's really easy to see what the next line of code is. That's my personal take on it anyway. Alright. So that's pushed, that's in there. Feel free to go and grab the code and try it out if you're on i3 especially. Like I said, you got to turn on that feature. What was it? i3 global full screen. And then when you use the full screen toggle in Looking Glass, which is the escape key by default print screen and F, you should full screen across all your monitors if that's turned on. That's really cool, in my opinion. I'm stoked that was actually fairly simple to implement in the end. And with that said, that's the end of this stream. So thanks for joining, and I hope that you enjoyed it. If not, I hope you learnt something. If not, too bad. This is how I work. I'll catch you all later.